This is video number 4 for sample exam number 2 for Math 107. I'm sorry, that problem that had several parts got moved over 2 videos. That wasn't good planning. Anyway, the problem before was shooting a pop bottle rocket off 20 feet on a 20-foot high building, and then watching it return to a height of 24 feet instead of 20 feet. Okay, and the solution for when the rocket hit 24 feet, there were 2 times, one on the way up and one on the way down, and as a result of using the quadratic formula, let's see here. So as a result of using the quadratic formula, the solutions look like this. T equals 1.56. Why does it keep doing that? Okay, 1.56. Let me get a highlighter here. So here was the solution. And you remember when I said write it with the plus or minus sign in between and the 2 fractions, one in front and one in back. And the reason for that is that leading term minus b over 2a is your h. And that's what you get right here. This 1.56 is the h for the vertex of this parabola. So now find the maximum height. Alright? This shows that you could have done it a different way, what's written here. But basically, you just take the 1.56, put it back in the original equation, work through it, and you find out this pop bottle rocket went a little over 59 feet high. So now you can go ahead and sketch it. On the t squared term, the coefficient is negative, therefore it opens down. It's going to start at 20 at times 0. It's going to hit the peak, its vertex, in 1.56 seconds. At that time, it's about 60 feet off the ground. And about 3.04 seconds, it's back down to 24 feet. And here's a graph of it. And it's true. On the actual exam, the problem is much easier, and you can actually factor it. For these 2 problems, you need to determine the type of roots. And you find, okay, there's 3 types of roots. Real, distinct. Second type, real, equal. And third, complex conjugate pair. Not imaginary, complex conjugate pair. So that's real and distinct, real and equal, complex conjugate pair. And the way you determine this, and you don't have to solve it, the way you determine it is look at the discriminant. And the discriminant is the part of the quadratic formula that is under the square root sign. Oh, by the way, the quadratic formula will be written on the test. Now, does this mean everybody is going to get the quadratic formula right? Unfortunately, the answer is no. Even with it sitting right in front of you, people put all kind of sign errors and strangeness to it. But you will have the quadratic formula available to you, and so if you practice just copying it over a couple times, then maybe you will be spared those problems. So what is sitting under the square root sign is this discriminant, b squared minus 4ac. So you have your quadratic function, and you make sure it's equal to 0. Then you can identify a, in this case, what happened to it? A is going to be 3. B is 4. C is 1. You plug it into b squared minus 4ac and see what you get. If the discriminant is greater than 0, you have real distinct roots. And this is something you have to memorize. If it's equal to 0, they're real, but they're equal. And for the complex case, if it's less than 0, they're a complex conjugate pair. Complex conjugates. Alright? So in this case, it turned out to be 4, so the roots are real, distinct roots. Now, in the second case, the big important thing here is that you cannot identify A, B, and C until you have everything on one side equal to 0. So I have to put that 21 over on the other side, and actually I went and changed signs, which you can do easy enough as long as you're consistent in it. But here's what I get when I put the x over there, and then move the 21 over and multiply through by minus 1, you'll get the same equation, or you could have put everything over onto the right hand side. Now you can identify A, B, C. A is what multiplies the x squared term, that's 10. B is what multiplies the x, that will be a minus 1. C is a constant term, 21. Substitute that into your discriminant and you find out that it's minus 839. It's less than 0. If it's less than 0, the roots are the complex conjugate pair. I'm going to discuss this problem first, then the extra credit problem. Here's a case. Sensitivity to a drug is related to the dose X. X is the dose, how many milligrams you give of the drug. And here is the equation for this. The sensitivity equals 1000x minus x squared. Right? This is a quadratic. Use the symmetry of the parabola to find the dosage at which the sensitivity is a maximum. Alright. So here's how you do that. If you remember that if I have a parabola, let's say the parabola looks like this, okay, first of all, where's the dosage, where's the sensitivity going to be at the maximum? At the vertex. Obviously, this is the parabola opening down. See the negative sign in front of the x squared? Okay, if you knew this root and this root, remember the roots of the solution of the quadratic equation, if you knew those two, the h would be halfway in between them. Can you find x1 and x2 from this equation easily? Yes, because it factors so easily. If you remember, there were several homework problems on this. So if I have 1000x, well, it's 100, minus x squared, I can factor out an x. Here's the x. 1000 minus x. Now, what are the roots of this equation? I want to find out where it's 0, right? To find out where it crosses the x-axis here. Okay, x1 is obviously 0. It's just out there by itself. If x1 is 0, then the whole equation is 0. Now I have to look at this part, and I would say x2 is 1000. So obviously my picture here doesn't represent it, but that's okay. I think we can fix that. We just get rid of it. All right. Now, I know that, well, that's great. This should be 1000. Okay, by symmetry, the vertex is halfway in between. Halfway in between 0 and 1000 is 500. So some errors in that homework, in the sample exam, I better fix those. Okay, so all you do is find x1, x2, and average them. So here's the extra credit problem. This used to be a problem and everybody'd miss it, but some people would get it, so I went ahead and I still think it's good. Also, when it's extra credit, people seem more motivated to do it. So the idea here is you have this wind chill temperature. Part of the reason it's on here is because the book had it wrong, and I spent a long time getting this wind chill temperature factor right. So I guess I have some loyalty to it. You're given this equation. All right, the temperature, including the wind chill, for a certain range anyway, at 25 miles per hour, it changes, is 1.32 times the ambient temperature. Ambient temperature would be your still air temperature. Let's just say it's air temperature A. Okay, minus 23.6. So you would put your air temperature in here, still air temperature in here for TA, work it through, and you find your wind chill temperature, what it feels like. Okay, now this following in linear inequality, and I give it to you. You do not have to develop it. This is the linear inequality to be solved if you want to find temperatures that will feel at least 30 degrees colder than the actual air temperature. You don't want to deal with just 5 degrees colder or 10 degrees colder. You want the range that's going to feel at least 30 degrees colder. So you're given this right here. You're given that inequality, and you need to find A, TA, the air temperature. Right? How do you do this? And it's really not so hard. It's just when you look at it, you might say, oh, I don't know what to do. So what do you do when you don't know what to do? You just write it out. 1.32 TA minus 23.6 less than or equal to TA minus 30. Okay, what is this? It's linear, right? And how do you solve a linear equation or inequality? You isolate the variable. Remember, in a quadratic, you put everything to 0, factor or use a quadratic formula, and come up with two solutions. For a linear equation, you isolate the variable. The variable is TA. Pretend it's x if you have a problem with that. So I want to get everything on one side, so I could add 30 to both sides of the equation and move the 30 over here. Then I could move those terms over here and divide. Okay, I'm going to do that on the next page. So here is the equation, and I want to isolate the t, or TA. So in this case, I could add the 23.6 to both sides. I was doing it the other way when I talked to you, but here, this works too. If I add that, I move this term over to this side. That works fine. Now subtract the TA from both sides. Okay, when I subtract TA from both sides, I get 0.32. TA has to be less than or equal to negative 6.4. So now, to isolate the TA completely, I divide by 0.32, both sides. TA is less than or equal to negative 6.4 divided by 0.32, which is minus 20. On the exam, if you get this far, that's full credit, full extra credit. You do not have to work out. Don't spend time dividing. Make sure your concepts are right, not your arithmetic. I know you know how to do arithmetic. I also know that if you had a question, you would just pick up a calculator. So that's the test, sample exam number 2. It includes this problem that's extra credit. You can study it and see how it works. It's really not that hard. Other than that, there's just the quadratics in here, a little bit on complex variables.